Yeah, all right, kiddies, welcome to your second video lesson for Chapter 5. Today we're going to talk about graphing linear functions. So again, this whole chapter is going to be graphing lines. Today we're going to look at the first and really the easiest way to graph a line is by graphing using something called an intercept. So let's jump right into it. All right, so first of all, let's talk about what the heck an intercept is. So we're going to be talking about graphing lines today. So again, this entire chapter we're going to be looking at functions of lines. So today we're going to start to introduce the first way in which we're going to graph, and we're going to graph by something called an intercept. An intercept is a word you probably have heard before. Intercept, you can think, what the heck does that word mean? Intercept means to cross. Okay, so the simple definition I'm going to give you, and there's a better definition, I'll talk about it later, but the simple definition of what an intercept is it's simply a point where the line crosses an axis. So you have two intercepts for any line, and it's the X-intercept and the Y-intercept. So the X-intercept is simply the point where the line crosses the X-axis, hence the X-intercept. And the Y-intercept is the point where the line crosses the Y-axis, hence the Y-intercept. So first thing is, can we, given a graph of a line, can we identify where these two intercepts are? So looking at the first example here, we have ourselves a graph, and here's our line in blue. Just to review some things from last section, remember that when we look at a graph, the axis that goes left and right, this is called the x-axis, and remember the axis that goes up and down is the y-axis. So when we talk about the x-intercept, is the point where the line crosses the x-axis. Okay, so if the x-axis is right here, where does the line cross? Pretty obvious here that the line crosses at 2. So that means the x-intercept is at x equals 2. Okay? The y-intercept is where the line crosses the y-axis, so we can look down here. Now, what point would that be? I'm going to go down 1, 2, 3, so that's going to be at y equals -3. So that means my two intercepts would be 2 and -3. Okay, next one. Where does the line cross this one? Now, okay, first one, the x-intercept, we notice here, where does it cross the x-axis, Well, you got to be careful here. Notice it goes 0, 1, 2. It doesn't cross exactly at 1, doesn't cross exactly at 2, but it crosses exactly in the middle between 1 and 2. So what would be the value between -1 and -2? That would be x equals -1.5, halfway between 1 and 2. Okay, so an intercept is not always going to be a nice, pretty, perfect point. It sometimes might be a decimal. And the y-intercept, again, where's it across the y-axis? I look down here. Oh my God, same thing. Y equals -3. Now notice here, depending on where my intercepts are, here the x-intercept's at +2, here it's at -1.5. My y-intercept was the same in both cases. Notice the differences of the line. So these intercepts really determine what the line is going to look like. Okay, this where the intercepts are one's positive, one is negative. Notice how my line goes up and to the right. We'll talk about this next section, I believe, but we say that this line is positive because notice how it goes up and to the right, up and to the right. This one, notice how my x is negative and my y is negative. The line goes down and to the right. If we track left to right, it goes down and to the right. This would be considered a negative line. Okay, so that's just something to point out there. Again, we'll come back to that next section. Now, the last one. Here's my line in blue. The x-intercept, where does it cross the x-axis? Oh my gosh, well, if you notice, it doesn't cross the x-axis. So is there an x-intercept? In this case, let me go back to red here. In this case, there is no x-intercept. So the point here, does it have to have an x, or does it have to have an x or a y-intercept? No. Sometimes it might not cross that axis. But in this case, it does still cross the y-axis. So if we look at that point, this would be at y equals 4. So it is possible to have no intercept at all. Is it possible for a line to have no intercept, no x and y-intercept? That's not possible. Okay, it has to cross at least one of the axes, if not both. Now, again, talking about last two examples, how we said this one goes up and to the right, down and to the right. We said positive and negative. Well, what would be happening here? Okay, it's not positive. It's not going up and to the right. It's not negative. So what's between positive and negative? Think numbers. If I have -1 and +1, what's the number between? It's 0. So this line we would describe as having or as being 0. Okay? All right, so a couple things going on here, just being able to identify intercepts. Okay, so now let's do the opposite. If I give you the intercepts, let's see if you can graph the line. So the first one, we have the X-intercept of -5. So if I plot that point, I know that there's going to be a point right here at -5. My Y-intercept, where it crosses the Y-axis, is right here at +5. If I draw the line between, sorry if my lines aren't going to be perfectly straight, but my line would look like that. So if I graph the intercepts, you are automatically given a line. Now, this is kind of going ahead for some of you that might take geometry, will take geometry. In order to draw any line, and maybe I should have mentioned this right away, in order to draw a line, you need to have at least 2 points. Okay, you can't draw a line with 1 point because a line has what's called direction, and that's where that positive comes into play. We need to have 2 points in order to define where that line is going. Next one, we have an X-intercept of 2. So if I look at my graph, X-intercept is going to cross at +2, and it's going to cross the Y-axis of -3. So those are my 2 points. Now I can see what the line is going to look like. So I'm going to connect those 2 points with line. Notice when I draw my line as well, I am not just going from point to point, but I am extending the line beyond the points. Okay, extended here down and to the left, extended here up and to the right. Because lines go on forever. They don't just stop at 2 points, but they're going to continue through those 2 points and continue on in that specific direction. Next one, we have X-intercept of 4. So that means at +4 on the x-axis is where the line's going to cross. But then it says there's no Y-intercept, so it's not going to hit this axis at all. So what's the line going to look like in this one? Well, how can it not cross the Y-axis but go through that? Is instead of the last example, how we said it was 0, it's going straight up and down. Now, just pay attention to that. That's a pretty good straight line for having it hand-drawn, don't you think? That's pretty frickin' impressive. But nevertheless, here, it doesn't cross the Y-intercept. If you think about this, some of you might know the term, doesn't cross an axis. That means it's parallel to that axis. That might be something, whoopsie daisies. That might be something you want to jot down. If it doesn't cross, that means it's parallel. All right, next thing. So what if we talked about graphing a line, or finding the intercepts from a line, graphing a line given the intercepts. Now we're going to talk about our first form of linear functions. Okay, so this right here is what's called standard form. Standard form is the basic form in which we identify a linear function. I use this idea of linear functions because remember we're talking about inputs versus outputs. Inputs we describe as x. Outputs we describe as y. So we have an equation that has both x and y in it. So what we're going to talk about is how do we actually graph a function given it in standard form. So standard form is going to look like this. It is written always as ax plus by equals c. So x plus y equals c. Now what are a, b, and c? A, b, and c they're called coefficients. Coefficients is a number in front of a variable. So A, B, and C are all numbers. And so we might want to just jot down A, B, and C are all numbers. Not hashtags, but they're all numbers. Okay, they're not tweeting about anything or twittering about anything. I don't know what you say, but they're numbers. So for example, we have this one. We have 2x, 3y equals 6. So A would be 2, B would be 3, C would be 6. So the question is, how do I figure out where the intercepts are if something is written in standard form? Because what we're going to do today is, again, graph by finding the intercepts. So if you go back, and I'm just going to sketch a little graph here. So here's my axes. Here's my line. Here's the tricky part about the intercepts, and I skipped this definition early on. But what is an intercept? Okay, so for example, this intercept right here, let's say that it crosses the x-axis at 2. I'm just making that value up. If I were to ask you, what is this point? Yeah, it's at an x value of 2, but a point in general, this is going to be at 2, 0, right? I would go right, 1, 2, and then I would go up, nothing. What would be if this y-intercept was at 1? What would be this point? Well, it would go right or left nothing and go up 1. So this would be at a point of 0, 1. So notice that if you look at any of the points, the x and y-intercept are when the other value is equal to 0. So the x-intercept occurs when y is 0. So let me write that down. The x-intercept, I'll write that below here, occurs when y is 0. So I'm going to put here x when y is 0. The y-intercept occurs when x is 0. You're going to have some value of y. So how do I figure this out then? Well, if I'm given this function, here's the idea. If the x-intercept occurs when y is 0, well, what can I do with y? Well, I can substitute the number 0. So that means I'm going to write this over here. The y-intercept, the x-intercept is what I'm going to find first, occurs when y is 0. So what I'm going to do is I'm going to keep my x in the function, but instead of y, I'm going to plug in a 0 because that's technically what the definition of an intercept is. It's where the line crosses the x-axis, but it's where y is 0, what is x. Now what ends up happening here? 3 times 0. Well, this completely drops out of the equation. So what I get is 2x plus, not plus, I'm going to get 2x equals 6. And that is something that we should be able to solve for. Divide by 2 on both sides, what I get is x equals 3. So this tells me that my x-intercept is at a value of 3. Okay, so what I did is I just plugged in 0 for y. So what do you think I'm going to do if I want to find my y-intercept? Well, I'm not going to plug in 0 for y, but I'm going to plug in 0 for x. So I'm going to say 2 times 0 plus 3y, and I'm going to keep y in the equation, is equal to 6. Here the 2 times 0 is going to cancel out because that's equal to 0. And what I'm left with is 3y equals 6. Divide by 3 on both sides, and I'm going to get y equals 2. Okay, so this one tells me my y-intercept is at 2. And now that I have those two values, I can simply draw the line between them by just connecting the 2 points. And there would be my line. Okay? Now, I'm going to show you a quicker method to do this. What ends up happening is when you plugged in 0 for y, that term completely canceled out. When you plugged in 0 for x, this term completely canceled out. So I'm going to show you a quick way to do this. This is called the cover-up method. Okay, so if you want to solve these quick, you'll write this down. This is called the cover-up method. So for example, when I want to find the x-intercept, here's what I'm going to do. I am going to cover up y. Okay, I'm going to cover up y, and what am I left with? Well, I'm left with negative 5x equals 10. Because why am I covering it up? Well, I'm covering it up because if I were to plug in 0, it would drop out anyways. So I'm basically covering this term out because it doesn't make a difference when I find the intercept. And what I'm left with is a simple equation. Divide by negative 5 on both sides, and you're going to get x equals negative 2. Okay, so I know that my x-intercept will be at negative 2. Now, if I want to find the y-intercept, then I'm going to take this value, or this cover-up, this box, and I'm going to cover up the x. So to find my, so that was my x, to find my y-intercept, what I did was I took and covered up the x and said 2y equals 10. Why can I cover up the x again? Because what we saw over here is that when you plug in 0, that's going to cancel out, and now what you're left with is just a simple way, or simple equation. So I can divide by 2, and I'm going to get y equals 5. So it's a quick, easy way to find these intercepts. Then I can plot the 2 points and draw the line between them. I'll do as best I can. Ooh, that's pretty good. And then I have my line. Okay, so the quick way to do this is called the cover-up method. All right, last thing here, I just got 2 examples for you to try. I want you to take these 2 equations written in standard form. I want you to find the 2 intercepts in graph. Notice, lastly, this first example, I do give you an extra problem down below, so I want you to think. We talked about this last lesson. I want to know, is negative 5, 10 a solution to this equation? I had a brain fart for a second. Here we go. Pause the video, give it a shot. All right, let's take a look at what you got. First one here to find the x-intercept. Again, what I did, I didn't necessarily show the object here, but to find the x-intercept, I covered up the 4y. Then I got 5x equals 20, and then x equals 4 plotted that point. Y-intercept, I did 4y equals 20. Divided by 4, I'll show you this. I covered up the 5y. There you go. I get 4y equals 20. Then y equals 5. Plotted that point, drew the line between those 2 points. Next one says, is negative 5, 10 a solution? So remember, if a point is a solution, don't forget about this. What we're going to do is take this point and plug it back into our equation of 5x plus 4y equals 20. If I plug it in, I get 5 times negative 5 plus 4 times 10 equals 20. Then I get negative 25 plus 40. That's multiplying these two things. Add these together. Negative 25 plus 40. I had to draw it over here because I ran out of space. Is 15, which does not equal 20. So no, that point is not a solution. So don't forget that if a point solution, it must make the equation true. Last one, a little sassy here. I have 2x equals 12. Let me bring this over here. For the x-intercept, I have to cover up y. There's no y, so I'm not going to cover up anything. So I have negative 2x equals 12. Dividing by negative 2, I get x equals 6. Plotted that point there. Now, why is there no y in this equation? Why does y disappear? Well, I can't, if I cover up x, well, there's no y. There's nothing to solve for. What is that basically telling me? That there is no y-intercept here. So it does not cross the y-axis, only crosses the x. Must be a up and down, what's called a vertical line. All right, so again, this is graphing by being able to find the intercepts. Hopefully you're able to identify the intercepts, draw a graph using the intercepts, and then lastly, finding the intercepts in standard form. All right, so we will see you in class. Good luck on the practice problems, my friends, and also on your mastery check. Again, if you have any questions on anything you did in this section, make sure you write it down and bring it to class. All right, kiddies, peace out. Big Dogs out.